Given question, draw shear force diagram and bending moment diagram for the cantilever carrying uniformly varying load.
This is the question of cantilever carrying uniformly varying load, where load is equal to 0 at the free end and load is equal to 2 kN per meter at the fixed end, and the total length of this cantilever is 4 meters. To draw the shear force diagram as well as bending moment diagram, we have to first find out the formula to calculate shear force and bending moment at any distance x from the free end. So we will first show this distance x from this free end A. We will consider the point D at a distance x. Now we have to find out the load acting at point D. So I will show here the load at this point D. Now if we observe, this is the uniformly varying load where this AC is the common inclined line. Now how to find out this load? That is, we have to find out the value DE. Now if we observe this diagram, there are two similar triangles with ABC and ADE. So we can take the ratio for base to the height. So in triangle ABC, base is AB and height is BC. So AB divided by BC is equal to AD divided by DE. Now we know the value of AB. So AB is equal to 4. Then BC. So value of BC is 2 kN per meter. So we have to put this value is equal to AD. So AD is distance x and DE, this value is unknown. So how to calculate DE? So with cross multiplication we will take 2x by 4 which is equal to x by 2. Now if we observe, here is x meter and this length is 4 meter. So this x meter and 4 meter, the meter unit is getting cancelled and here unit will become kilonewton per meter. So value of DE is x by 2 kilonewton per meter. We will understand how to calculate shear force at a distance x from the free end A. We have to first calculate the total load. If we observe the distance x, that is the span AD, then the load is uniformly varying, where the load at point A is equal to 0 and the load at point D is equal to x by 2 kN per meter. So for uniformly varying load, how to calculate the total load? So this total load is equal to area of triangle ADE, and this area is equal to half multiplied by base multiplied by height. So we will write here half multiplied by AD multiplied by DE. So AD is equal to x and this DE is equal to x by 2 kN per meter. So when we simplify this, we will get x square by 4. Now we will find out point of application of this load. So how to find out? So I will draw here the second leg where I will show this point A. I will also show this is the point D. Now where is the point of application of this load? So this load x square by 4 is in kilonewton. So we know that from this free end where this load is equal to 0, point of application of the load is 2 by 3 multiplied by this total distance x. So I will write here 2 by 3x. And where this load is maximum, that is at point E, from this point D to E, this is at a distance 1 by 3 multiplied by the total distance x. So I will write here 1 by 3x. So here is that point, and this point is the point of application of the load. So this uniformly varying load I have shown here with this point load, and this is the point of application of load, and this load is equal to x square by 4. Now how to calculate shear sign convention. Suppose I have shown here this section XX. So point of intersection with this horizontal line and vertical line, if I consider a particular point, then the load on the right hand side which are in downward direction, we will consider the positive sign, and the load which are on the right hand side but in upward direction, we will consider the negative sign. In the same way, for this point of application, if we have to find out shear force at any particular point, suppose I will say P, then if the load is on the left hand side and the direction is upward, we have to use positive sign. If the load is on the left hand side of this point and the direction is downward, then we have to use negative sign. So we have to first mention this sign convention in the answer, and then we can find out the shear force. So we will find out the shear force at point D, where this D is at a distance x. So how to find out this? So if we observe, this is the point where we have to find out shear force. Now this load is on the right hand side and direction is downward. So when load is in the downward direction and right hand side, we have to use positive sign. So SF at D, we will use plus x square by 4. Now we will find out SF at B. So at point B, this total distance x from the free end is equal to 4. So instead of x, we will put here the 4. So I will write here plus, because in the same way we have to take positive sign, because if we observe the point of application of the load for this span AB, then it is also on the right hand side and in downward direction. So instead of x, we will put here the value 4, that is 4 square by 4, that is equal to plus 4. Then SF at A. So at A, this distance x is 0. So when we put x is equal to 0, then we will get the answer 0. Now for the accuracy, we will find out the load at the middle point. So if I take any middle point where x is equal to 4 by 2, that is 2, then what is the load? So if I take point P as a middle point, suppose point P is here, then how to calculate this? So SF at P. SF at P. Now instead of x, we have to put 2, that is 2 square by 4. So 4 by 4 is equal to 1. We will calculate bending moment at a distance x from this free end. So how to calculate that? So we have to first understand the sign convention. When this bending moment on the right hand side of the any point, suppose we will consider this point P. Now when it is in clockwise direction, then we have to consider negative sign, and when it is in anti-clockwise direction, we have to take the positive sign. Now the bending moment on the left hand side, when it is in anti-clockwise direction, we have to take negative sign, and when it is in clockwise direction, we have to take the positive sign. So we have to mention this sign convention in the answer, and we have to calculate the bending moment at point D, which is at a distance x from this free end A. Now if we observe, here is the point of application of the load. So if I move the compass about point D in the direction of this point of application of load, then it is in the clockwise direction and this load is on the right hand side. So here this is the bending moment with negative sign. So we have to take the minus sign. Now what is the formula to calculate bending moment? So we know that it is load multiplied by the distance from this point D. So this distance is 1 by 3 into x, and this load is x square by 4. So we will take minus x square by 4 multiplied by 1 by 3x, which is equal to x cube by 12. So this is the bending moment at point D. Now we will calculate the bending moment at different points. So bending moment at B. So BM at B. So at point B we know that this x is equal to 4 meters. So when we put here 4, then 4 cube divided by 12. So we will simplify this. So it is 16 by 3. So we have to consider negative sign for every bending moment. So here minus and here also minus. Then bending moment at point A. So at A, this distance x is equal to 0. So when it will become 0, then bending moment at point A is 0. Then bending moment at point P, where P is the middle point. So bending moment at P, where x is equal to middle point, that means 2. So 2 cube, 2 multiplied by 2 multiplied by 2 divided by 12. So which is equal to 2 by 3. So we have to mention here with negative sign. Now with these values, here the bending moment and shear force at point B, A and P, we have to draw the SFD as well as BMD. To draw the shear force diagram, if we observe the equation in terms of x to calculate the shear force, then it is in terms of x square, that means 2 degree equation. So we have to show this shear force with parabolic curve. And if we observe the bending moment to calculate at any distance x, then it is in terms of x cube. That means to draw the bending moment diagram, we have to show it with cubic curve. Now we will first plot the values. So to draw the shear force diagram, we have to show here the baseline. Then the positive values we have to plot in the upward direction. So first SF at A. So at A it is 0. So we will mark here 1 point. Then SF at B, it is plus 4. So we have to mark 1 point at B. And SF at P, it is plus 1. So here we have to mark 1 point. Now we have to join this. So we have to join this with parabolic curve because it will follow the parabolic curve. We will complete this. We will show here the value plus 4, plus 1 and 0. Now in the same way we will show the bending moment. Now for bending moment at A, 0. So we have to mention these negative values in the downward direction of this baseline. So I will mention here 0 on the baseline at point A. Then at point B, it is minus 16 by 3. So for to plot the actual value, we will simplify this. It is minus 5.3, and to plot this bending moment at point P, we will simplify this. Minus 0.66. So here we will plot the value. So it is at B, it is minus 5.3. So here this distance is plus 4. So I have to plot here minus 5.3. And at P it is minus 0.66. So it is nearer to this 0. So I have to show here minus 0.66. So no need to show here the negative sign because we have to show these values in the downward direction. So no need to show the sign. Now we will connect this.